Lesson 53 is on adding and subtracting polynomials. So let's first talk about what a polynomial is. We've dealt with monomials, which has one term, and we've dealt with binomials, which has two terms. And then there's trinomials that have three, and then anything that has more than three is considered a polynomial. Okay, the degree of the polynomial is the greatest degree term in the polynomial. So whatever has the highest power when you add them together. And we'll talk a little bit more on that in the next slide. It'll make a little bit more sense. Okay, leading coefficient is the coefficient of the term with the highest power, and standard form is when the terms are in order from least to greatest. So for finding the degree of the polynomial, so here's a great example on the side. Okay, so if we look here, z has a 1 power. To find the degree of the polynomial, we're going to add up all of those exponents. So 5 plus 3 plus 1 gives us a power of 9. That's the, okay, and this one here has a power of 1 for the x, and when we add them, we get 4. And then here our y has a power of 1, so when we add them, that gives us a degree of 5. So this one is going to be the degree of the polynomial. So let's look here. For a, my y has 1, so 2 plus 1 plus 6, we have a degree of 9. Okay, in B, my x, my y, and my z all have 1 power, so it's a degree of 3. It has nothing to do with the exponent on that 2. In C, we have a 1 with the x. Again, ignore this 2. So 1 plus 2 plus 3, we find a degree of 6. Okay, write each polynomial in standard form and find the leading coefficient. All right, so we are going to put the one with the highest power first, which ends up being this one. So negative 2w to the 4th plus 3w squared, because the 3w squared is a positive. So now it's in standard form, and my leading coefficient is the one that has the highest power, so that's negative 2. All right, so let's look here. This has a degree of 3. This has a degree of 4, and this has a degree of 2. So we're going to put our 3a squared b squared first, and then we're going to write our one with the next power, lower power, so 5ab squared, and then our 8ab plus, oops, not plus 1, minus 1. And my leading coefficient then is my 3, so you want to write that out. Okay, here we have a degree polynomial 2 there and 3 here. So negative 5a squared b comes first, plus 2ab and minus 7. The one that doesn't have the variables is always at the end. Okay, my leading coefficient then is my negative 5. Add the polynomials and write each answer in standard form. Okay, so when we're adding between the two parentheses, we can actually just ignore the parentheses. And then just add like terms. So something we've done plenty of times before. So 2x squared and x squared gives me 3x squared. Okay, and then I just have an x, and then I have an 8 and a 4, so plus 12. It is in standard form because its highest power comes first. All right, so I'm going to just rewrite this one. 3n squared plus 7n minus 1. Plus negative 2n squared minus n plus 1. So I'm looking for the highest power first, so 3n squared and a negative 2n squared. 3 minus 2 gives me 1n squared. Then I have a 7n and a negative n, so 7 minus 1 gives me a positive 6n. And then my negative 1 and my 1, those cancel. They give me a 0. All right, subtract the polynomials. So here, this one we can't just drop our exponents or drop our parentheses. We need to actually distribute in a negative 1 to all three of those terms. So the first one stays the same. Now everything in the second one is going to be times the negative 1. So I get minus 18y cubed. So negative 1 times negative 3 turns into a positive 3y squared. And negative 1 times a positive 5 gives me a negative 5. All right, so 12y cubed minus 18y cubed, we get 16y cubed, or I'm sorry, negative 6y cubed. Okay, then we just have a y squared plus 3y squared, and then 10 minus 5, we get a plus 5. All right, so distribute your negative here to all three of those. And when you go ahead and add like terms, you should get 8c minus 8. All right, Hector throws a baseball up into the air, and at the same time, Jonas throws another baseball upward. The expressions below represent the height of the baseballs at time t. So write an expression for the difference in height. So we want to take then Hector's equation or expression, and we're going to minus Jonas' expression. Okay, so I'm going to remember to distribute my negative. So I should have negative 14t squared plus 22t plus 4. Now, negative times a negative is going to turn into positive 9t squared. Negative times positive, so I get negative 17t. And negative times positive, I get negative 6. Go ahead and combine your like terms here. When you do so, you're going to get negative 23t squared plus 39t plus 10.